conditional statements to actually define geometry terms. For example, perpendicular lines. I could write the definition of perpendicular lines using a conditional statement, which means I could put it in if-then form. So I could say something like this. If two lines are perpendicular, then they intersect to form a right angle. Since that's the definition of perpendicular lines, that's definitely true. I could have also written the converse of that. Okay, if instead of they intersect to form a right angle, again, I need to identify what they refers to. So I would word the converse of this statement, something like this. If two lines intersect to form a right angle, then they are perpendicular. And then that would be true as well. So if we talk about perpendicular lines, let's just say line L intersects line M at a right angle. And then we talked about before, so you should be familiar with the symbol, to show that these two lines are perpendicular or form a right angle, I could put a little square in the corner there. I could have put a square in this corner, or this corner as well. That shows that those two lines are perpendicular. Or I could use symbols as well. It's not really logic symbols, it's just geometry symbols to show that these two lines are perpendicular. Besides making a little square in the corner like this, I could say L, that's line L, is perpendicular to line M. So the upside down T means that the two lines are perpendicular. That's the symbol for perpendicular. Just like last year in algebra, maybe you went over the symbol for parallel. We'll talk about that later. The symbol for parallel are just two like vertical bars right next to each other. These lines aren't parallel, but they are perpendicular. So both the hypothesis and conclusion could be switched for the converse. The converse is true. So this conditional statement is true. The converse is true. If a conditional statement is true and the converse are true, so both of those requirements have to be met, you could write what's known as a biconditional statement. Okay, so again, a biconditional statement can be written if both the conditional statement and the converse of that conditional statement are true. So they both have to be true, otherwise you actually would not be able to write a biconditional statement. Every biconditional statement contains the words if and only if. And then that phrase or those words have to be in the middle. So here's an example, the definition of perpendicular lines written as a conditional statement. So if two lines are perpendicular, then they intersect at a right angle. That's definitely true. The converse of that statement, if two lines intersect at a right angle, then they are perpendicular. That's also true. Since both the conditional statement and the converse of that conditional statement are true, I could write a biconditional statement. There's two ways that you could write a biconditional statement. This is the hypothesis of the original conditional statement. This is the conclusion. So I take the hypothesis and the conclusion. I don't want to start with if for a biconditional statement. Every other statement that we wrote, a conditional statement, the converse, the inverse, and the contrapositive, we started with if. All of those were if-then statements. For a biconditional statement, it actually does not start with an if. It contains the words or the phrase if and only if, again, in the middle. But here's one way that I could write the biconditional statement. Two lines are perpendicular. If and only if they intersect at a right angle. So it basically would look like this. P, if that's a hypothesis, if and only if, Q, that would be the conclusion. So they intersect at a right angle. The other way that you can write the biconditional statement is like this. Q, if and only if P. So without writing it out, just going over it orally, the biconditional statement could have been something like, if two lines intersect at a right angle, sorry, it actually wouldn't start with if, two lines intersect at a right angle, if and only if the lines are perpendicular. So you could actually switch hypothesis and conclusion for your biconditional statement. Either of those would be correct.